Welcome everybody. It's a pleasure to be here in Melbourne on a nice sunny day. I am Polak. I'm coming from Tel Aviv. It's somewhere far in the Middle East. And today we're going to speak about Kotlin Coroutines and how you can get started with it. So usually here you see a slide about the speakers saying, why you should listen to them and why you should care. But the thing is, this talk is not about me. It's about you getting started with coroutines. So basically, we're going to discuss only about coroutines, but I do want to mention the team that I'm working for at Microsoft. We are a team of cloud advocates, and our main mission is to help every technologist on the planet to succeed at what they do. So if you're fond of cloud technologies, AI platform that provided by Microsoft, we can help you get better and get the best education for free to get started and be an expert on the cloud. So I'm part of this amazing team. Some of them are based here in Melbourne, some of them in Sydney, and we're all over the globe, also traveling a lot. So if you see us, just come say hi. We're super friendly, always helpful to come and ask questions. We're trying to help everyone. And if we don't have the answers, we'll help you find them. So please, if you see us, come say hi. So today is the day where you finally going to understand how to use Kotlin coroutines. And what we have on our agenda is very basic intro to Kotlin, assuming you know a little bit here and there to come and learn about coroutine, and then some common use cases for coroutines. And then we're going to discuss the questions that I see a lot, like, can you really compare coroutine and threads? What does that even mean? We're going to go over some very basic concepts so you can get started as fast as ever. We're going to see some demo with code that I created for you. And then we're going to discuss about some frameworks that you can use later on that use extensive coroutines in their code. So let's start from the beginning. What is Kotlin? Kotlin is a program language that's developed by JetBrains. And if you don't know JetBrains, maybe you know IntelliJ. So JetBrains are the developers of IntelliJ and a lot more awesome IDE tools that probably saved me at least once or twice. Kotlin powers all of JetBrains tools. Kotlin is an open source language, so you can actually go and dig in and see how they implemented all the cool features. So that you can get both things, also learning about how they implement it and also learning how the best way to use it. It's 100% interoperable with Java. It's recently declared as the first language on Android. So Google came with a great announcement saying all Android development that we're going to do is going to be based on Kotlin. So Android Studio, you can get Kotlin outside of the box. And what's the cool features about Kotlin? Well, there's a list of cool features, but the main thing we mostly see, it's null safety, higher order functions, data classes, extension functions, which are super fun. And since Kotlin 1.1, they also introduced coroutine. They have a lot of more fun features, but today we're going to focus on coroutines. Sorry. So let's jump into the common use cases. So there is a lot of use cases for why you want to use coroutine, but there's two common ones. So if you're doing a server-side development and you're working with a microservices architecture, most of the times, you're going to use a lot of network. So when you use a lot, because your system is distributed, and when you lose a lot of network, the threads get stuck. They get blocked. They're waiting for response sometimes. But the thing is, you don't have to. Because with coroutine, it's a non-blocking, you can build a non-blocking architecture. So it can really help to use it in when you build microservices. Another common use case is the Android app development. Did you ever have an app that you tried to scroll through, but then it got freezed? So it's not about the app being shitty or your device being shitty. Sometimes it's just about, you create some calls and then the main thread gets stuck because we're waiting for a response. So the thing is, with coroutine, you don't have to block the main thread. And we're not blocking the main thread. It gives a better experience for the user to use your app. So another extensive usage is Android app development. And the reason it's so, it's because it's asynchronous and non-blocking. So now that we know a little bit about the use cases, the question that comes up all the time is, can we really compare coroutine and threads? A lot of people always ask me, like, what is it, like a better thread? Like, what does that mean? So the thing is, you can't really compare it. In most places, you kind of call it a light thread, but it's not a thread at all. It's actually running by a different system. So basically what we have within a thread, we can create a lot of coroutines. And then we can manage it by the language itself. So let's see how it works. Let's say we're going to talk about concurrency in threads. So in threads, what you usually have, we have the scheduler. And the scheduler helps us decide the amount of time a specific thread is going to run. And we usually use run-robin scheduling. And run-robin scheduling is which each task gets the same amount of time to run until it finishes. So basically, the operation system stops the thread, no matter what it does. It stops it, and it says, OK, now I'm going to give this resource to a new thread. And this is the concurrency manner. And it's always, we always limited by the amount of cores we have. Because on one core, we can run only one thread at a time. So when we're talking about parallelism, we're talking about having multiple cores. When we're talking about concurrency, we can also do like only one core with a list of threads that we run sequentially. And this is managed by the operation system, which can be highly intense on RAM. So this is why we have the concept of thread pools, because we can create all the threads that we want in the world. We bound to the amount of cores that we have. And then we have coroutines. And coroutines, some people say, are kind of lightweight threads. But the thing is, coroutines are managed by the Kotlin runtime. And there's no specific scheduler there. As you can see, the sizes of the coroutines could be different. And what it does, it basically creates some suspended functions. It basically said, this specific coroutine is going to run, and the coroutine itself is responsible to say, here you go, I'm done, or I'm waiting now, take the resources, and now you run it. So it creates something we call yield. It says, OK, yielding back the resource, we don't need it, we're now running into some stop and resume process. And this is why we're not blocked by a specific time slot that we can run. We can basically use the CPU as much as we need, and then yield back the resource to the next coroutine. But here we can see we have this two lists of coroutines that are running, which basically helps us create the parallelism that we want, which we get by using threads. So that's very nice. We understand a little bit about concurrency. We understand a little bit about use cases. But the thing is, how do we get started? So there's a few main concepts that you need to know before you can start. So now I'm going to cover only the basics one, only the one you need. And later on, you can always extend and learn more. So we're going to talk about suspending functions. We're going to talk about channels. We're going to talk about builders. And we're going to talk about content and scope. So let's talk about suspending functions. Suspending functions basically are the center of everything in coroutines. It's a function that can be paused and resumed at a later time. And they can execute like a long-running operation and, without us blocking the rest of the process. The syntax of the suspending function is similar to the one of a Kotlin function, except that we use the suspend keyword that you can see here. So basically, we add suspend before the declaration of the function, which tells us that now it might do a blocking work. But under the hood, what we have, it's basically an object called continuation. And continuation, it's kind of a callback pattern that we get, which basically say, this is the value we're gonna get back from this specific functions, and it's of type int, because the some background task returns int, and this is how it translates under the hood. This is how it compiles too. And this is basically how you do suspend. The next common thing that you need to know is about coroutine context and scope. So what is coroutine context and scope? So the thing is that coroutines always need to be executed in some scope and in some context. And basically, the context is a set of various elements. Behind the scene, we have kind of a map between context key and context element. It holds everything the coroutine needs in order to run. It's basically represent the coroutine context class in the Kotlin X coroutines, if you ever saw this library. And it helps us find the thread that we're running in, the specific information about the job. It's also helps us decide which one of the information we want to get back. So if we want to get the information about the specific job, which is the actual coroutine that's running, we can call the coroutine context and give it the name of the job, and then it's going to return us the details of the job. And what's good about it is we can decide if we want to stop it, if we want to resume it, or what we want to do with the specific jobs that represent our coroutine. Another information that we get from the context is the dispatcher. And we have multiple dispatchers, and we can also decide which dispatcher we want to work with. And the dispatcher helps us realize in what threads we're running in. So dispatcher defaults, we usually get it for free. It's out of the box, usually inside a default, it's our default value. And the thing is, behind the scene, Kotlin holds thread pool. So we're not dealing with threads at all. Behind the scene, we get it for free. Kotlin decides the amount of threads we're going to use by the system. And then we can say, OK, just, we trust users, use the default, use the thread you want to run it within. And that's the dispatcher default. The second one is dispatcher main. It's mostly used in Android development, and it's represent the main thread that runs. Especially when you have UI or tasks like that, we want to make sure we're not blocking the specific thread. So if we're using it, we want to make sure to use it with coroutines so it's not blocked. So we can say, OK, just use the dispatcher main, and we usually have only one thread to the dispatcher main. Another dispatcher is the I/O. And the I/O is optimized to run I/O tasks. It has a limit on the amount of threads it can run. It's usually 64, or the amount of cores, so the higher one of the two. And it basically helps us do a more I/O extensive task, and it's also optimized for that. The last one is the unconfined one. And this is still experimental API, so use it with great care. And the thing is it's that one thread can start running the coroutine, but then it's get to the suspend function. And when it gets to the suspend function, it might be that another thread, a different thread, might finish the task and return the answer that we're waiting for. So this is still an experimental API, so just be aware of how to use it. The next thing is about coroutine scope. And the scope basically represents our scope in the code. And our scope in the code says, OK, now it's going to be about, now we're going to enter a coroutine scope. And in order to connect between the two, we need to use builders that we're going to see later. But here you can see from the function signature that this is the launch function with signature, that it can receive some coroutine context, or it can get a default value like we have here, the empty coroutine context. And it returns a job with all the details that we need. Next one are the builders. And actually, the builders also act as bridges, because they connect between the non-coroutine world and the coroutine world. So what we basically, they're kind of creating this connection between those two worlds, because we can't call suspend out of coroutine's world, out of coroutine scope, so we have to use them. And two of the main functions that are more common is launch and async. So we saw the signature of launch, and we know it returns a job. So actually what launch do is basically create a new coroutine in the background and return a reference to it as a job object. And the builder, what it does, it's a fire and forget. You call it, and that's it. It doesn't return any value back. It just returns the job so we can control it later if we need to. If we need to stop it, or if we need to do some things around it, if we want to check some exceptions, we can do it from there. And they inherit the context that we spoke about from the scope of the coroutine itself. The next one is async. Async is a little bit similar to launch, but the thing is, it returns back a value. So if you know promise or future, it's kind of like that. It returns a different object that we call deferred. And deferred actually gonna hold the value that the suspended function is gonna return. So they're pretty similar, but with async, we're expecting to get a value back. And for those who used coroutine in the past, they changed a little bit the API, and now we have to call launch and async from coroutine scope. Kotlin folks did it in order to keep it, the suspending functions in a structured way, so it's sequential and not jumping from one to another. And the last one we're going to talk about is run blocking. And run blocking actually creates its own scope. It stops the main thread, and it uses the main thread to run now this specific block. So everything outside of it is blocked, and now we're just going to run whatever we have inside the run blocking. And from there, we can call any suspended functions that we want. So this is the run blocking, and we'll see a code example of that later. So putting it all together, we have the coroutine context scope and builders. So this is an example of how you can use it. So let's say I have a specific coroutine scope, and I have to mention I'm using this specific coroutine scope. And then I'm calling the launch builder that basically takes me from just the coroutine scope into creating the actual coroutines that I need. And it gets two different contexts in here. So here I say, OK, I want dispatcher default. And I'm concatenating another context that I wanted to use. I'm concatenating a context that's called coroutine name, which basically gives a name to the coroutines that's running. The thing is that I can concatenate them because behind the scenes, there's a map and key value. And we need to be very patient and understand how it works. Because basically, behind the scenes, it might override some of the keys. If I have key duplication between the two contexts that now I'm concatenating, it might override some of the keys I have. So please use it with care when you're doing that. And from there, within, I'm calling some suspending task that we saw before. So this is how you put everything together. Our last concept, basic concept of today, is about channels. And basically, channels, it's a non-blocking primitive for communication between the sender and receiver. So what we can do, we can create two coroutines, or even more, and say, OK, this specific coroutines is focused on sending, and the other specific coroutines is focused on receiving. So we can create a sender-receiver pattern. And there's multiple ways we can use the channel. And here's just a few examples, but you can also implement your own channel. So what we see here, we have the first channel is a rendezvous channel, which means the sender and the receiver are both going to be blocked until they're both available to run together, because there's no actual queue between them. So the sender creates the information that the receiver won't receive, but they need to be available at the same time. The conflated, it's already have a queue, but it has a queue of size 1. So if the sender sends message and the receiver didn't process it yet, the next message it sends is going to be overridden. So we need to take great care when we decide to use this thing, because we might lose some data of the communication between the way. The third one is buffered, and here we can decide what's the size of the buffer we want to use. So you can see from the animation, we have here we're actually using two different channels. The second one is the conflated one, and the third one is a buffered, and the one down below, it's the buffered one, where we can keep different amount of messages that we want to process, and then we're sending it to the coroutines according to availability. So we have two coroutines running the same task, and both of them are processing it. And the fourth channel options is the channel unlimited, which is basically implemented with a linked list behind the scene. So you can create as many messages as you want, but you can also get out-of-memory exception if there's too much and the receiver doesn't process it. So use it with great care when you decide to use the unlimited one. So since I'm from the Middle East and falafel is very common, I've decided I'm going to do some coding of a falafel kiosk. So let's do that. Sorry? Can you see it? What's that? Yeah. For some reason, it doesn't take it. Awesome. All right. So I created a few sealed class so we can get started with. And we're going to have some falafel balls and different type of falafel balls that we can do. Like we can have them fried or we can have it oven cooked. And then we have different kind of salad that we can run with. And I created a price function that we can override. And then some mixed salad. But the thing is, this is the important part, is the menu, what is offered on the menu, and the actual dish that's being processed. So what we're going to do, we're going to basically get information about the order we want to do, and then we'll see how we're going to do it. So this is basically an example of how you can run it without any usage of coroutines. So here we have the main function, and in the main function we have a list of orders. So we have 4 different orders, and we would like to measure the time of how long it takes to run it. And then we're going to log it. But what happens inside, basically, that we go over each order and we make it. And inside there, we basically check the type using when is. So if the type is just a falafel in a pita, we're going to create a falafel in a pita. But the thing is, so those functions are kind of have a sleep within them, meaning it's going to take some time to create this specific salad, or it's going to take some time to create this falafel balls, which actually mimic the blocking that we have. And then we have, later on, we have the assembled dish itself, depends on which one we're assembling, and then the logs. So let's run this. So we can see some log, we can see that it's processed, and the thing is, it's processed sequentially without using any coroutine. So only the main thread, and it prints out everything it does, process it by one, and then say, okay, this whole orders took 165 milliseconds, which is nice, but we're talking about coroutines, so we want to see how we can make it there. So we have here the same thing, only with coroutines, and we have the same 4 orders. This one is the same one that we saw before. And later on, we have few options to run it. So one is just the falafel with coroutines to see how it works. The next one is falafel with coroutines and dispatcher. It's the one we talked about, when you can say, okay, just use the thread pools that we need to use. And then another one's going to be falafel with channels, where basically we're creating 2 coroutines that are going to run together and process the orders. So let's see how it looks. I'm just going to take this variable and put it outside, so it's going to be easier for us. All right, for some reason it doesn't like it. Okay, deal with that later. So let's see how we create falafel with coroutines inside. So as you can see, I used the suspend keyword to make sure the compilers knows that this function can be blocked. And here inside, I have a coroutine scope. I'm using the builder launch to start the coroutine inside. And then I'm going order by order, and I'm creating the falafel with the suspending function. So basically, everything here inside is suspended. And how we can mimic the sleep of the threads, because here we don't want to pause the whole thread. We just want to say something like, OK, just pause this specific coroutine. So in order to do that, we'll just take one of the functions, like get solid suspended, and we're going to see that we're using a function called delay. And delay comes from the coroutine library, which basically kind of mimic what sleep does, but it doesn't stop the whole thread. Because if we're going to use thread point sleep, and we know actually that coroutines are running within a thread, we're actually making blocking the thread. So here we're just going to call the delay that's given to us by the Kotlin language. So we're doing the same thing with all the functions. Get solid suspended. We're gonna do a delay for 2 times the time of solids we're gonna create. And then we have the get falafel ball suspended and assemble plate suspended on everything we need inside. So let's see how it looks like. Now we're actually going to run it twice, once with coroutines and the second time without coroutines. So this one is the one without the coroutine, and this one actually took us 114 milliseconds. The other one is within the coroutine, but the thing is, you can see the thread that's running it, and the thread that's running it is part of the main. And the reason that the thread is running it is part of the main is because we're using the run blocking. Like we said, it's blocked the whole main thread and basically transfer it to run the specific block. So this is why we see it's here it's printed as main. And now we're going to print it with the actual time. All right, so it usually takes 116 milliseconds, but when we're running it with coroutines, it takes 103 milliseconds. But it can change. It really depends on your hardware and what you're working with. So that was nice. That was, falafel with coroutines. But let's see how it's going to work with falafel and coroutines and dispatcher. And like we said before, the dispatcher here basically gives us an information about the thread pools itself. And we're using run blocking, which means we're going to use the main thread, and then we're using the dispatcher default, which is going to say, use the pool that you need, use whatever thread that you need. So here it's the same thing. We're running it within the coroutine scope. We're using the launch builder, which is a fire and forget. And then we use the dispatcher default, and we give it a specific coroutine names. Here it's falafel routine with thread pool. And then just we call the make falafel one. So now when we're going to run it, it's going to give us the times and also the name of the thread that's running it, or information about the specific worker that's running it. So as you can see, the basic one took 112 milliseconds. And the second one with the dispatcher, oops, forgot to print the time. Just going to add the time now. But the second one is going to take way less just because we're using, again, coroutines. And now we can see that we actually run it from a different worker. So it gives us information about where we're running it. And the thing is, how it gives us information, it's basically because I'm using a special log function. And within the log function, I'm actually calling the current thread that runs, and I'm taking the name just so we can see what's the name of the thread that's running this specific task. So now you know that behind the scenes, threads and coroutines working together in order to give us a better performance. So now the last one, it's going to be about running it with channels. And with channels, like we said before, we can launch as many coroutines as we want, and we can also say, okay, so now basically you can send the data to the one coroutine that is available to read. So now we can have two coroutines running the same task, but receiving different orders. So first thing, we need to create the order channel itself, and we just call the channel factory, and we give it the type of data it's going to receive in the channel. And here we're going to specify the coroutines that the channel is going to run, and it's also going to run launch, and it's going to go for every order, it's going to do the acting of order channel and send. So we're basically sending the order to whoever is listening on this specific channel. And one important thing that we need to remember is to close the channel, because otherwise it's going to be open. So make sure you're closing the channel. Some channels are closed by themselves, but check whatever channel you're using so you'll be on the safe side. So now that we configure the channel, we want to actually launch the coroutine who processed this order. So here we have two calls for launch to launch this coroutines. We have falafel routines 1 and falafel routines 2. And the difference here that the function receives a channel. Like now we're not getting the order, we're not getting the menu anymore, we're receiving the channel, and the channel is in charge of giving us the specific type that we need. So how we're doing it, we're basically reading from the orders channel, and the orders channel is this type of receive channel that gives us the information that we need inside. And now we're going to run it. So we're always comparing it to the one without the coroutines. So the first one without the coroutines took us 160 milliseconds. But the second one with channels, where we split it to two different coroutines that can process it, took us only 82 milliseconds. And the reason for that is basically because of the delay. We call a delay function, but then we didn't block the whole process. We just said, okay, we're now going to give the resources to the next coroutine that's needed. But here you can see it's all running on the main thread. We didn't add any threads, and we still save time because of the non-blocking functions that we have. So now let's run everything together. Right, so the first one now, without coroutines, without anything, took us 140 milliseconds. That's nice. The second one with the basic, very basic coroutines took us 102 milliseconds. The third one with the dispatcher and the thread pool took us 92 milliseconds. And the last one with the channels, with 2 different coroutines that are still using the same thread, took us 65 milliseconds. So basically, when we're looking at that, we need to first understand what our needs are, and then actually using the channel and creating 2 coroutines to share the same resource of that specific thread help us process everything in lower time. Right. So this was our demo. Now let's talk a little bit about framework. Today there's a lot of framework, there's a lot of libraries, it's always evolving, it's always, people always adding new open source to the world. This is a few of the more common one. So Ktor is basically used in the server side, mostly for building microservices or web servers, and it's highly extensive on coroutine. If you're doing microservices or you're working within the server side or putting together a web service, definitely try it out and see how it works for you. Another known library is Vertex. It's for event-driven and non-blocking tasks. It gives us a lot of cool function outside of the box, and it can handle a lot of concurrency using small number of threads. Like we saw before, it uses a lot of different manipulation, channels and stuff, but it helps us use a small amount of threads, especially when we're working with Android development. The last one is Arrow, and Arrow is actually another layer on top of the Kotlin API that we have that gives us a functional programming approach. So if you're into writing type functional programming, definitely look into Arrow. It's kind of new, but it's still evolving and very exciting library to use. And as always, you know, there's people behind the scenes that, you know, supporting the open source, creating all the amazing content, all the amazing educational stuff so we can get started. And these are only some of them. Some of them work by JetBrains and do an amazing job, and some of them just, you know, people that are excited by it from the community that gives their time and effort to make this language great. So a short summary of what we saw today. We understand why and what is coroutines. We understand what's the thing with coroutine and threads and how they work together. We saw some basic concept of how you can get started. We created some falafel with coroutines, and we saw some frameworks and things you can do. And also stood on shoulders of giants who did a lot of work before us. And now I have a question for you, now that we've finished our session. What will you build with Kotlin coroutines now that you know all the basic concept of how to get started? Yeah, thank you.